Hubble believed there could be alternative explanations for the redshift and was hesitant to conclude that it unequivocally demonstrated galaxies were expanding. Furthermore, the fact that there was a past expansion of galaxies does not necessarily imply that galaxies are presently expanding. Telescopes can only observe the past, not the present. The Bible indicates that the heavens were once stretched out, as mentioned in various passages. If the Big Bang theory is accurate, the early universe would have been filled with a uniform distribution of gases. This uniformity would have prevented the gases from clumping together due to insufficient gravitational attraction, hindering the formation of stars and planets. Big Bang proponents proposed the existence of dark matter to provide the necessary gravitational force for the formation of galaxies and stars. However, there is currently no empirical evidence supporting the existence of dark matter. In fact, the concept of dark matter has faced increasing skepticism within the scientific community. While Big Bang proponents argue that dark matter is the only explanation for certain galactic behaviors, others have presented an alternative theory called modified Newtonian dynamics, MOND, suggesting that dark matter may not be necessary to explain the observed movement of galaxies. Dr. Dwayne T. Gish, a late creationist and scientist, argued that even if dark matter existed, it could not account for the formation of the massive galactic structures observed in the universe. He also emphasized that while gravity can maintain order, it cannot explain the origin of that order, which suggests the involvement of an intelligent force. Some astronomers who adhere to evolutionary principles propose that trillions of stars collided with each other, leaving surviving stars to settle into precise orbits. However, this hypothesis is problematic because it would leave behind a significant amount of gas clouds and dust in space which is not observed. The current level of gas and dust residue in space does not align with the magnitude of star collisions required for this hypothesis. It is more reasonable to believe that stars die and decay into gas clouds and dust rather than gas clouds and dust evolving into stars as suggested by evolutionary astronomers. These astronomers often assert that gas clouds and dust, such as those in the pillars of creation, are the birthplaces of stars, despite this claim being speculative and lacking concrete evidence. In an intriguing attempt to interpret Webb's observations, a scientist proposed a hybrid model blending aspects of the tired light model with a cosmological model based on evolving coupling constants. This new model suggests a longer time frame for galaxy formation, allowing for the development of well-evolved early galaxies. However, further investigation is needed to ascertain whether this model can adequately explain all cosmological observations. This approach of combining models to explain new observations is not unprecedented in science, as evidenced by Albert Einstein's work on the dual nature of light and the estimation of the universe's age based on the ages of stars in globular clusters. The discrepancies between observations and the standard cosmological model have led to the proposal of a new model suggesting a longer universe age. While this new model holds promise, more research is required to verify its validity and its ability to explain all cosmological observations. It's worth noting that James Webb's sharp vision recently uncovered two of the most distant galaxies ever observed, supporting the fundamental concept of galaxy formation in the Big Bang theory. This discovery was made possible by the gravitational lensing effect of the galaxy cluster AEL 2744, also known as Pandora's cluster, located about 3.5 billion light-years away. This cluster's immense gravity bends spacetime, magnifying the light from more distant galaxies. Using the James Webb Space Telescope to search for early galaxies magnified by this gravitational lensing, Bingo Wang from Penn State College of Science and a member of the Uncover team discovered two of the highest redshift galaxies ever observed. The cosmological redshift caused by the universe's continuous expansion results in the stretching of light wavelengths. The farther a galaxy is, the more the universe has expanded during the journey of its light across space, resulting in a stretching of the light's wavelengths. This stretching transforms the light from tighter, bluish wavelengths to redder ones, eventually falling into the infrared region of the electromagnetic spectrum. Galaxies that existed between 300 and 400 million years after the Big Bang have had their lights stretched into these infrared wavelengths, which are invisible to humans but detectable by the Webb's near-infrared camera and near-infrared spectrometer instruments. Wang and her team successfully identified the lensed images of two high redshift galaxies. One of them, designated Uncover Z13, has a redshift of 13.79%, placing it in the universe just 330 million years after the Big Bang. The other newly discovered galaxy, Uncover Z2, has a redshift of 12.393, ranking it fourth in the all-time list of most distant galaxies. This galaxy gives us a view of the universe as it was just 350 million years after the Big Bang. What sets the two Uncover galaxies apart is their appearance. While other galaxies seen at similar high redshifts appear as point-like dots indicating they are very small, possibly only a few hundred light-years across, the Uncover galaxies exhibit structure. Wang explained, previously discovered galaxies at these distances appear as a dot in our images, but one of ours appears elongated, almost like a peanut, and the other looks like a fluffy ball. These galaxies are also larger, with Uncover Z12 featuring an edge-on disk approximately 2,000 light-years across, which is 6 times larger than other galaxies seen from this era. The reason for this size difference is uncertain and could be due to how the stars formed or what happened to them after formation. Nonetheless, the diversity in galaxy properties at this early stage is fascinating. Even at this early stage in the universe, the contrast in galaxy properties is striking, but both of the newly discovered realms exhibit characteristics that strongly align with the Big Bang model. According to this model, galaxies initially formed small and then rapidly grew through mergers with other galaxies and gas clouds. This growth stimulated further star formation, leading to an increase in the abundance and variety of elements within these young galaxies, including substances heavier than hydrogen and helium. The galaxies uncovered by Uncover, pun intended, are young, small, have a low abundance of heavy elements, and are actively forming stars, all of which supports the Big Bang theory. Joel, an assistant professor of astronomy and astrophysics at Penn State University and a co-researcher on Wang's team, commented, interestingly, the Webb telescope has the ability to see even higher redshift galaxies than Uncover Z13 and Z12, meaning they'd be even younger, but it didn't detect any being lensed by the Pandora cluster. As Elle said, that could mean that galaxies just didn't form before that time and that we're not going to find anything farther away, or it could mean we didn't get lucky enough with our small window. Astronomers will keep looking using a multitude of lensing clusters to open up new windows into the deep universe in search of some of the first galaxies. Out in the vast expanse of space, the James Webb Space Telescope is already transforming our understanding of the universe. For the James Webb, the discoveries are coming in rapid succession, with each image unveiling new wonders, from the distant corners of the cosmos to the planets within our own solar system. Our first glimpse came a year ago. The images were nothing short of breathtaking. The Kina Nebula, Stone's Quintet, and the stunning deep field image revealing thousands of galaxies stretching across the cosmic horizon. Yet, perhaps the most astonishing revelation from James Webb is the discovery of ancient, fully formed galaxies that defy our current understanding of cosmic evolution. These universe breakers, as scientists have dubbed them, appear to predate the universe itself, presenting a profound mystery that challenges our fundamental theories of the cosmos. Could these revelations from James Webb signal a crisis for the Big Bang theory and modern cosmology as we know it? Join us as we delve into the implications of James Webb's groundbreaking discoveries and their potential to reshape our understanding of the universe's origins. The concept of the Big Bang originated from 3 key observations embedded within Einstein's general theory of relativity. First, that a universe filled uniformly with matter or energy cannot remain static and must either contract or expand. Second, the observation of spiral and elliptical galaxies beyond the Milky Way, with their distances and red shifts indicating an expanding universe. And third, the conclusion that if the universe is expanding today, it must have been denser and smaller in the past. Georges Lemaitre was the first to synthesize these insights in 1927, followed by independent confirmations from Howard Robertson, Edwin Hubble, and Arthur Walker. This framework led to further deductions, such as the early universe being hotter and denser, and as it expands, it cools. This cooling process was predicted to leave behind a remnant radiation known as the cosmic microwave background, which we observe today as a confirmation of the Big Bang theory. The universe, in even earlier stages, would have been sufficiently hot and dense to trigger nuclear fusion reactions before stars could form, resulting in an initial abundance of elements beyond hydrogen among the universe's primordial atoms. Subsequently, as neutral atoms emerged, gravitational forces led to the formation of structures. Stars, star clusters, gas clouds, galaxies, galaxy clusters, and eventually, the intricate cosmic web comprising filaments and voids. These aspects of the Big Bang have been confirmed and validated, eliminating many alternative theories unable to replicate these achievements. Presently, 3 additional components have been identified and verified in the universe. Dark matter, which clumps and gravitates but does not interact with normal matter or light. Dark energy, which acts as an inherent energy in space itself. And cosmic inflation, which constrains how far back in time we can extrapolate the hot Big Bang before matter and radiation no longer dominate the universe's energy content. This framework allows us to describe the universe's initial conditions at the onset of the hot Big Bang. Its temperature, density, the initial spectrum of density variations, and their magnitudes across all cosmic scales. Our understanding of the Standard Model, coupled with dark matter and dark energy, enables us to determine the types, energies, and abundances of all energy species across various cosmic epochs. Using this foundation, our knowledge of the universe's governing laws and interactions enables us to evolve these initial conditions from the hot Big Bang's inception to the present day. Through theoretical predictions and numerical simulations, we can anticipate the universe's evolution in an expanding cosmos that originates from a hot Big Bang and adheres to the properties we have ascertained it should possess. Nevertheless, despite the extensive observational support for this framework, it may not be entirely accurate. Each time we observe the universe in a new manner, we must ensure that what we see aligns with this model. With the recent inclusion of the James Webb Space Telescope in astronomers' arsenal, doubts about the Big Bang theory persist as its early universe observations defy explanation by current cosmological models. The James Webb has ventured further into the universe than any previous NASA instrument, providing humanity with its first high-definition view of the infrared cosmos. Matt Greenhouse, a project scientist who has been part of the James Webb senior staff, remarked, "Thanks to Webb's unprecedented capabilities, for the first time we're beginning to discover and characterize galaxies found in these very, very early stages of our cosmic history. Previously, the universe's early epochs were characterized by a single confirmed galaxy, GNZ11, existing approximately 400 million years after the Big Bang, with only one additional galaxy candidate possibly dating back to around 330 million years post-Big Bang. There were no other stellar or galactic signals observed from such early cosmic eras. However, since the commencement of James Webb's scientific operations, the narrative has significantly shifted. Over 100 galaxy candidates identified by James Webb now extend our view back to the first 400 million years of the universe. Several of these candidates have been confirmed as truly ultra-early and distant. GNZ11, once the farthest known galaxy, has now been surpassed and ranks 5th in distance. It is anticipated that in the coming months, not only will the current record for cosmic distance held by JAYS GS13 at just 3 out of 20 million years post-Big Bang be broken, but also that numerous new ultra-early, ultra-distant galaxies will be validated. Many of these early galaxies discovered by James Webb exhibit peculiar and perplexing characteristics that challenge the theoretical framework of the universe. These galaxies appear exceptionally massive, luminous, enriched with heavy elements, actively forming new stars, and rich in gas. The abundance of galaxies with these traits in the early universe raises questions because we understand the processes of gas and star formation, which should limit their growth. While certain conditions can temporarily overcome these limits, sustaining such rapid growth over long periods seems improbable. Thus, the existence of these early galaxies suggests a discrepancy between observation and theory. The galaxies observed by the James Webb Telescope are of such immense size that they appear incompatible with current cosmological theories. This unexpected discovery has left astronomers studying the Big Bang theory astonished and perplexed, as these galaxies seem to contradict the predicted outcomes of the theory. According to the Big Bang theory, the early universe should have consisted only of primordial dust from which stars and galaxies were assumed to have formed following a primordial explosion. The findings of the James Webb Telescope are challenging the widely held Big Bang theory, causing unease within the scientific community, particularly among those who subscribe to the theory. Advocates of the Big Bang theory proposed that the expansion of galaxies in the universe originated from a singularity that exploded billions of years ago, While some galaxies do exhibit an expansion indicated by redshift, not all scientists, including those in the field of evolutionary science, interpret this redshift as evidence of galaxy expanding or of a primeval Big Bang event that gave birth to the universe. David Rowland, a Canadian physicist and scientist, highlights several scientific inconsistencies with the Big Bang theory in his article, "The Big Bang Never Happened." Rowland argues that prestigious science journals refuse to publish research that challenges the Big Bang theory, leading dissenting scientists to publish their findings on the internet. He contends that the redshift is not a measure of velocity, indicating galaxies moving away and expanding, but rather a measure of temperature and distance. Rowland asserts that early scientists mistakenly equated the redshift from galaxies with the Doppler effect, leading them to believe in the expansion of the universe. He explains that the light from galaxies naturally diminishes over vast distances, a phenomenon that early scientists erroneously interpreted as evidence for the expansion of galaxies in our universe. This initial misconception, once established, became a cornerstone of modern cosmology. Even Edwin Hubble, the renowned astronomer after whom NASA named its telescope, expressed skepticism about interpreting the redshift as evidence of galaxy expanding.